Welcome to the 52nd lecture. We are studying complex power. Before we solve a numerical problem related to complex power S, complex power is represented as S. It's a complex number. We have a small recap. S is obtained by multiplying V with I, multiplying V and I, where V is the voltage across load or across source or across line, where I static is the complex conjugate of the current flowing through that element. It can also be represented as a complex number. Its magnitude, angle, magnitude and angle. If this I has an angle theta I complex conjugate of I will have an angle minus theta I. It can be represented as this in the form of a polar in polar form, but in rectangular form it can be represented as P plus JQ, where P is the active power or average power and Q is the active power, and Q can be positive or negative. For inductive loads it's positive, and for capacitive loads this is negative. This is what we studied in last lecture. In this lecture we will solve an example where we are given a source, a line which is supplying a load. It's a 0.8 power factor lagging load, drawing active power 20 kilowatts, and the voltage across load is 220 volts RMS. This is RMS voltage, 220 at an angle of 0. So we are supposed to find S in load, the complex power absorbed in load, the complex power absorbed in line. This combination of inductor and resistor is called line, and the complex power absorbed in source. As a first step, we will find the complex power absorbed in the load. We know P absorbed in load, the active power, it's 0.8 power factor, it's at 0.8 power factor lagging, and we know it's VL, and we know that S absorbed in load would be VL times IL. If you know RMS value of VL and IL as complex numbers, fortunately we know this complex number. So the only unknown is, there is a static here, so the only unknown is IL, which you can find easily. We know power is P, active power is V RMS times I RMS times cosecant of theta V minus theta I. In our last lecture we have studied that is theta V minus theta I. Cos of theta V minus theta I is power factor. So V RMS I RMS into power factor. So P is known 20K, V RMS is known, it's 220 at an angle of 0, I RMS is unknown times 0.8. So solving this gives us an I RMS equal to 113.6, and since it's a lagging load, it's lagging at power factor 0.8. This means cos inverse of 0.8 is minus 36. So we now know V as well as I. This is V, this is IL RMS, this is VL RMS. VL, this is IL, and they both are RMS quantities. We know that. So understood that they both are RMS quantities. So how to find P? SL is VL times complex conjugate of IL. VL is this 113, VL is 220 at an angle of 0 multiplied by IL 113.6 at an angle of IL static means this is 36.8 degrees, but with a positive sign. So if we multiply these two quantities, we get S absorbed in load. S absorbed in load is 25,000 at an angle of 36.8 VA. We know the units of SL is VA. The units are VA. Then next is we have to find S line, and then finally the S, the complex power supplied by the source. So V line. So to find S line, we must know V line, and we should multiply it with the complex conjugate of I line as per the formula, and I line is the same as IL because of series circuit, right? So V line is, we have to compute the V line, we have to compute the value of V line because we know I flowing, we know IL flowing, the same current, we will multiply it with its C to find V. According to Ohm's law, we will first compute V in line, which would be, that would be I line times Z line. The current flowing through it times its impedance gives us the voltage across it. So I line, we have computed I line to be, I line was computed by us, is the same as IL, 113.6 at an angle of minus 36.8 degrees. We will multiply it with Z line, 0.09 plus J 0.3. You have to convert this number into polar form, and then we will multiply. So we get to the answer V line is 35.6 at an angle of 36.4 degrees volts. So this gives us V line. Now we have everything to compute S line, because to compute S line, the complex power is V line times the complex conjugate of I line, and I line is the same as IL. So V line is 35.6 at an angle of 36.4 degrees times I line, which is the same as IL, 113.6 at an angle of minus 36.4. We have to compute, we have to multiply it with the complex conjugate, so this minus would be converted into a plus. So S line would be 4044 at an angle of 73.2 degrees VA, volt amperes. So, and the last thing for this lecture is to compute the complex power supplied by the source, and that would of course be the complex power absorbed in load as well as in line. So we know from the theorem of total power that S supplied by this source is the S absorbed here and the S absorbed here, the complex power in line plus complex power in load. So S of line we have just computed, this is 25,000 at an angle of 36.8 degrees plus SL we have computed that is 4044 at an angle of 73.2 degrees. So we have to convert these into rectangular numbers, and then we'll add real part in real, imaginary imaginary, and then we'll convert back into polar form. So it's left as a small homework for students. 28,359 at an angle of 41.7 degrees will be your answer. It's given in my notes, you can verify it or you can do a small homework. In our upcoming lectures, we'll keep on studying AC power. Thank you.